Morning. Good morning. Welcome. We find out how scared people are of math today. It is showing the numbers here. How many are scared and how many are courageous enough to make it to this room? Oh, really? The ones who are scared are here. Oh, that's very interesting. For a large part of my life, I was sharing with Ian as we were sitting down. We used to have a camera outside the room, and the workshop used to be for kids who hated math. And they'd walk into the room, we'd record their expressions, and then walking out of the room, we record their expressions. I just wanted to see those expressions before and after. And the idea I got was from newspaper ads of people, and I'm just kind of chatting here for a minute as people come in. Newspaper ads I saw before and after with bald people, right? Before and after, you got treatment, and I said, okay, how about trying it with math? I hate math before and then after. And the only thing is you don't get to see the hair though, but you look at the expressions, and that could say a few things about please come on this side. Yeah, I think everybody will come a little bit because people will enter at different points. So I can request friends to shift onto this side, because I'm sure there'll be, you can have some space between chairs, that's fine. Just a few people on this side would be great. Yeah. So welcome everybody. I am grossly underqualified to be standing here and talking about math. I simply have a bachelor's degree in engineering, no math degree, but I fell in love with math as a 7th grader because of my teacher, who was my math teacher. And I'm in the company of someone who I wanted to attend the session with, but my friend Pavak said, no, you have to co-present. I said, what am I going to talk if Ian's going to be there? So Professor Ian VanderBurgh heads the Center for Education in Mathematics and Computing at the University of Waterloo. I only have been inspired by the work of the University of Waterloo over the years. When I used to be in my teaching and counseling days, I used to hear about the math workshops they do in schools. And they've just done some phenomenal work. Sita's here as well. Thank you for inspiring people in a world that is increasingly paranoid about math. There are so many courageous people who came for this session. So I'm grateful. Thank you, Ian, for your presence and for actually doing this at IC3 and supporting the work. So I'm going to hand it right over to Ian to get started.
Good morning, everybody. It is so wonderful to be here, to be able to talk about mathematics, to be able to share my love of mathematics, and hopefully send you out with those smiles on your face that Ganesh was talking about. I found myself, as he was talking, hoping that perhaps mathematics might help my hair grow back. But I don't think that's actually what he was telling me, but we'll see. Perhaps there's still hope for me as we go along here. Mathematics is a wonderful discipline with a complicated history. We have complex emotions when it comes to maths. So one of the questions that I have for you, and I would love for you to shout out an answer, when you hear the word mathematics, what emotions does that make you feel? Angry, magic, confusion, anxiety, problem solving, happiness. Oh, good. That's very good. The early in the morning maths is perfect. Higher dimensions, wonderful. Math cannot do. And our students have all of these emotions. Some of them are in the state where they just love it. They can't wait to get to math class. And some of them are in the state where they cannot wait to get out of math. But at the same time, math is such an important discipline. As the title of our talk says, mathematics is omnipresent in our world today. It is behind everything that we do all the time, even if we don't realize that. And it's really important that we help overcome some of these emotional barriers to maths, that we help teachers and students and parents and the general public understand the importance and value the importance of maths. There are, of course, stereotypes that we associate with the word mathematics. And I will be very honest with you, I think mathematicians don't always do ourselves any favors around this. We sometimes are our worst enemies. You might think, if you're good at math, that you're antisocial and reclusive. Maybe you want to become a monk. I don't know, Ganesh, whether that applies here or not. People think of mathematicians as smart. When I tell somebody that I teach math, particularly at a university, the first thing that everybody says, oh, you must be so smart. Well, I appreciate that, but that's not the point. People believe mathematicians are unaware of the world around them. People believe sometimes that mathematics are poor communicators, or that we are members of a secret society, that only we have the keys to. As I said, I think sometimes we as mathematicians don't do ourselves favors around this. Often we use nomenclature. We make up words that seem to just complicate the situation. And I really believe strongly in pulling back some of that. Let's make maths more real. Let's make it more transparent. Let's make it more understandable. I also believe this bottom left box here, poor communication. One of the most important skills that our students need to take out of the math classroom is communication. This is so vital because people who do mathematics in the real world do mathematics on teams of people, and people who are not themselves mathematicians, who are not necessarily mathematical themselves. We as educators need to teach our students to be good communicators of the maths. Yes, many of us love math because you can get to an answer. But the end point isn't necessarily the important part. It's the journey to get there. It's the path, it's the thinking. All of those things are a really important part of maths. Now, I'm so lucky here to be doing this session with Ganesh this morning because this is my second trip to India. We work with wonderful students from India at our university. I have wonderful colleagues in Sita and Pavak who have helped me learn so much. But it is somebody like Ganesh who really understands the context in India much better than I do in terms of the educational landscape. I'm going to turn things back to him for a minute here.
So I don't know if you noticed this. We've had a history of producing the CEOs of Google, of Microsoft, of financial companies. We're the most amazing in history with numbers. Further south you go, the stronger they get with numbers, right? I mean, from north to south. If you get to people like Anil and others down south, you could see yesterday what Krish was doing in the opening keynote, right? So in many ways, I thought that we were, in a way, the intellectual capital for math in the 70s and 80s, where IITians were coming out and other mathematicians were coming out and doing some phenomenal work. But if you see the news stories in the recent past, this is pretty common. There's research after research, and you're thinking about how math is the toughest subject, and scores in math in middle schools falling, and there's lots of fear around math. And there's the term math anxiety was something that I discovered in the newspapers. It was a pretty commonly used term, math anxiety. And it basically started to, in the last decade or so, we've, in India in particular, but even in other parts of the world, we started to identify math as the toughest subject students learn. They feel emotionally overwhelmed and have anxiety about the need to succeed in the subject. Many of them are rattled by failure. I have seen a lot of students going to their IBDP coordinators or their CBSE, can I get through school without math? And it is one of the most harmful actions to stop learning math after 7th or 8th grade, which is something that I was told by one school, 90% of their students wanted to drop math. And there used to be a subject in IB called math studies earlier, and everybody wanted to take that up. So that they thought they'd just escape the HL and SL, and it was the same in many other places. Students often, whether they attend tutorials and additional tuitions for other subjects or no, they almost always are attending tutorials for math. And that is very common. So I just want to share this, that we've gone from a country that absolutely produced geniuses with math and has been, we continue to produce geniuses with math, but we've actually got a very large number of people that are choosing careers in colleges based on their aversion or their fear of mathematics. And that is not good for your students. That's not good for their future. That's, as counselors, we need to appreciate what this subject really can do for us and where this subject stands in the global world order. So back over to you, Ian.
And our context in Canada is not that much different, I would say. It's very similar kinds of impressions, very similar kinds of feelings around mathematics and its importance. But of course, as a mathematician, one of the things that I believe strongly is we need to understand what we're talking about. When we talk about mathematics, what does that actually mean? Many people believe that mathematics is numbers. By doing math, it means we're performing operations on numbers. People who do mathematics in the real world often are not actually working with numerical quantities. They're thinking more. They're thinking perhaps in more abstract quantities and trying to balance, again, the concrete numerical with the more abstract thinking. Maybe mathematics is a large interconnected set of rules and facts that govern the universe. I think perhaps we've seen that in the last 24 hours as the lander landed on the moon yesterday. Is mathematics logical and analytical thinking? Is mathematics creative? Lots of people would say it isn't creative. But I would argue that mathematics is, in fact, all of the above here. These are all very important parts of what mathematics is. Yes, we start with the concept of number, but then we build rules and facts from it. And then we problem solve. We think creatively. We look creatively for solutions. We think analytically and logically. And those are really the fundamental skills that our world needs, the fundamental things that we want our students to come out of the classroom with. Our goals today, I think, are to understand that mathematics is vital to every part of 21st century life and society. Everywhere you look, if we look hard enough, we'll find maths underneath it. I would argue, too, that maths is the best path for today's students to follow. Many people say, well, you're good at math, but what will you ever do with it? Does it actually lead to careers? If you're good at math, you should become an engineer. Great career. You should become an actuary. Great career. You should become a maths teacher. Great career. But is there anything else? Maths leads to every career. And an ability and an interest and success in mathematics will lead students down any path that they want because they have learned how to think. Maths, I think, also really importantly is a field in which everyone can excel. Maths is not a secret society. It's not just for a select few who were gifted with a special set of brain cells along the way. We can all get there. We can all develop an appreciation for math. And part of it, I think, comes down to how we view math and how we approach math in the classroom. And that's not to say that any particular way of approaching math in the classroom is wrong. I'm not saying that. But I think having some complementarity between skills and thinking, between practice and problem solving, I think these work really well together. I am very lucky to work at a place where our mission is to promote mathematics. We promote mathematics to students in Canada and internationally. Our mission is to increase confidence, ability, enjoyment, and interest in mathematics among educators and learners in Canada and internationally. And we are really lucky to be able to be here to work with students and teachers, to do this all across Canada and in many, many other places. Many times our students, certainly our students in Canada do, perhaps your students in India are more polite than our students in Canada. Our students will ask, "You're teaching me something, when am I ever going to use this?" Have you heard this question before? Yes, yeah, we every day, right? I want to show you I want to talk about a couple of mathematical concepts briefly. And I recognize, full disclosure, that perhaps not all of you are mathematicians here. But bear with me here for a minute. In Canada, when boys and girls are young, they often do dot-to-dot puzzles. Have you seen, is this a concept in India? You join the dots. This is kind of a connect the dots puzzle, looks like it. This does not perhaps inherently look like a math problem. But here's a math problem for you to think about based on this diagram here. Imagine that you wanted to go along each of the lines here and end up at the point P. The question is, where would you have to start to travel along every line exactly once and end up at the point P? You couldn't, in fact, start at T at the bottom. If you started at T at the bottom and left T, you'd eventually have to come back to T and you'd be stuck. The same thing is in fact true with Q or R or U. But I could start at S, I could go down to T, up to U, back to S, up to R around the circle, down to U, up to P. It's kind of a fun challenge, feels like a puzzle. We look at this and say, yeah, I would find that interesting in solving this. Now imagine that you were a driver for FedEx and you had to do deliveries. Would you want to drive along any street more than once? Particularly in the traffic you have here in India? We have traffic in Canada too, but different kind of order of magnitude. Just for context, the population of Canada is smaller than the population of Delhi. And the area is 3 times the area of India. And it's not snowing in Canada right now, I'll tell you that for sure. But here is this field called graph theory. This is a part of mathematics where we think analytically and logically. We don't have to write down any numbers. We don't have to solve an equation, but we have to think mathematically. Trying to solve a real world problem efficiently is what this kind of thing is all about. Here's another kind of idea. There is a country in the world right now, and I'm not going to tell you what the country is, where the current birth rate is 0.8 children per woman. I'm going to make a whole bunch of societal assumptions, which I know are not true, but I'm going to make these just for the sake of working through this. Question is, how many great children will 100 people in this country have? So let's say we have 100 people, they form 50 couples. If every woman has 0.8 children, 50 couples will produce 40 children. 40, now those people grow up, they become adults. 40 people become 20 couples who produce 16 children. 16, those are grandchildren now. The 16 children form 8 couples. They're going to have 6-ish great-grandchildren. So there is a relatively well-known country in the world where this is actually the case right now, where 100 adults are going to produce 6 great-grandchildren. That's mathematics. It's modeling. We've worked through a real-world problem. But then one of the questions is, what are the societal implications of that? Means that we're going to have not very many young people to support people as they age. We're going to have a big imbalance in our population pyramid. And those are important questions that we need to grapple with, whether we're in a country like yours that is growing so rapidly, or a country like this that is shrinking rapidly. These are important 21st century problems that mathematics provides insight to. This is an area of mathematics that I might call modeling, where you're trying to take a problem that exists, a concept that exists, and try to figure out the math underlying it and use that math to make predictions. Modeling, of course, came very much to the fore during the COVID pandemic, where we saw all sorts of crazy models all the time. One good thing about models is that they help us predict. Sometimes there might be several models. We're not really sure what's going to happen. Let's follow one of these paths. My colleagues who are modelers will say all models are wrong by definition, because it's never going to play out exactly like we say. But that's not to say we shouldn't trust the math. We have to make assumptions to make models like we did here. One last picture to show you here. If you're trying to find a route between 2 places, perhaps using Google Maps as this image is here. This is from our city of Calgary in Western Canada. When we use a GPS, there's several things that happen. First of all, the GPS has to figure out where we are, whether that's your phone, whether that's a box in your car. What is the primary mathematical tool that the box uses to figure out where you are? It's the Pythagorean theorem that we teach in middle school. Our students learn what is an application of the Pythagorean theorem? The GPS. GPS uses the Pythagorean theorem and then systems of equations to find your location. And then we use different mathematics to figure out good routes. There's lots of math tied up even in that. And again, if you are a big industrial company that has thousands of trucks or trains or trucks or airplanes, and you're moving packages, you're delivering things, you're trying to get airplanes from Australia to Vancouver to Toronto to Delhi and back again, these are all problems that require mathematical thinking to be able to solve them. Here is how I like to view math, and you can see the arrows over there on the right. We start in maths education teaching very important skills, very foundational skills that we use to build up this body of knowledge that we call mathematics. Once our students have a good grasp of those skills, we need to move them into analytical, logical, and systematic thinking, into creative thinking, into visualization, into communication, into ability to abstract. I was at a school in Delhi on Tuesday afternoon doing some problem solving. And one of the things that we talked about was looking for multiple solutions. We had one diagram on the board and we came up with 5 different solutions to it. The students in the room came up with 5 different solutions, and we shared those solutions together. And the chance to do that is a really foundational part of doing math, doing it in a community, trying to learn from each other and find multiple approaches. Because it's those creative people, those creative problem solvers that take the phones that we used to have that plugged into the wall in our houses. And then we had portable phones that we could carry around our houses and talk to our grandmother while we were walking through the house. And then, of course, we had these things that we all carry around. And that's creative thought. Once our students have skills, and once they're able to work through these thinking skills, that problem solving kind kinds of techniques in the classroom lead to, then they're really frictions. What is it that employers want? They want people who can think logically, analytically. They can solve problems, they can communicate their ideas, and they can come up with creative solutions from time to time. Mathematics. That's what mathematics does and can do. I have here this word proof. And Ganesh had this on one of his slides earlier where there was this headline that said, hence proved. The word proof sometimes gives students the willies, right? They get all weird when we talk about having to prove things in mathematics. I want to share one story who I taught in our first year students when they come into our program. The very first math course they take is a course on proof. These are students, some of whom are going into pure areas, many of whom are going into computer science, many of them are going into mathematics and business kinds of programs. Why do we teach them proof? They're not going to go out into the world and prove theorems. A friend of mine who was a former student 20 years ago has said to me, he was a student in our mathematics and business program, and he has gone on to a very successful career in business. And he said to me one day, he said, Ian, you know, the reason that have been so successful is because I took your course on proof in first year. All of my peers have business degrees like I do. But the thing that sets me apart is that I learned how to think differently by studying math, by learning to prove things. He doesn't prove things, but it is something that has set him apart. Mathematics is a subject where balance is such an important part of it. We need to teach a balance between skills and thinking. We need to teach a balance between big picture. Mathematicians are good at, people who know mathematics are good at coming up with big picture ideas, getting a general sense of what's going on. But mathematics is also about precision. Again, to oversimplify something, if we got the long angle wrong by 0.1 of a degree, we would miss the moon by 50 kilometers. Probably not a good thing. That wouldn't have played over so well. Mathematics connections in the real world. This is an important thing that helps motivate some students. If they understand how this connects to the real world, this is a very hard thing for mathematics educators to do. But it's an important thing to work in from time to time, I believe, because it helps motivate some students. This focus on problem solving is also really important. And I think that relates to the second last point about the variety of future paths for our students. Some of our students are going to study mathematics and proceed into fields that are math. Some are going to study STEM fields and proceed in that area. Many of them are not going to do that. But if they can think mathematically, and we can help them get there through our mathematics education, they are going to be much more well-rounded citizens of the 21st century and able to do things. So it's that focus on problem solving, I think, that really helps. As well, I think at the bottom here of remembering what the most important things that our students should take from our math classrooms are. And for me, while I'm teaching my specific curriculum items, it's always it's about thinking. It's about helping our students learn how to think mathematically and logically. Yes, we're teaching the specifics, but let's keep those general things in mind. Now, mathematics is a discipline that interacts with the real world in so many different ways. And I'm going to turn things back over to Ganesh to continue to say some more about that.
Thank you, Ian. When I was a hopeless boy in school, I found my way with math. At time, I thought math was this beautiful island. I found peace. I just went and did math, and I could do math with music. I would how many of you did math with music like you used to play? Oh, so many of you. You know why it works so well? Have you ever imagined? Math works with music so well because there's a certain rhythm to math. There's a certain flow. And it's amazing how many students who love music hate math. When I used to do these workshops, I was like, you love music. How can you not love math? And then they got to see the music in math in the music, then their life changes. And I often told people, hey, you don't like math? Give up the chair. Never sit on your chair. There is all kinds of math involved in this creation of this chair. You don't want to, I mean, trigonometry, geometry. I don't want to get into the career counselors would say, Ian and I could probably get excited, although I'd know much less, but we get really excited. You know, sound waves are entering. I mean, my engineer in me says sound waves are entering this microphone, getting modulated, bouncing off the walls, whatever else, you know, I mean, and then whatever. And this is all math happening as we are speaking. You know, this whole conference is all about mathematics. This is the most important session in the conference. You know, this projection, this LED, everything is mathematics. You will not have chairs in this conference. You will not have tables. You have nothing. I mean, we need to determine what is the ratio of student volunteers to attendees. I do math all the time. When we hosted 200 people at an IC3 conference versus we are hosting 2,000 people, what's the ratio? And everything, portions, I mean, everything around us is math. No, really. And there's something very beautiful about this whole journey with mathematics. We just need to discover it. This fear is born, and this lack of understanding is really driving kids on the wrong path. As career and college counselors, you got to stop that from happening. No kid should give up math till 12th grade. In fact, they should do more math. They need to see math on the floor, math on the ceiling, math on their face, math on their tie, math in their hair. And there is math all around them. And it is as exciting as anything else. Doing math is like reading Harry Potter or watching a Netflix thriller. As exciting as that. It's just that they haven't discovered it. And so I would, you know, and you know, we have this very classical Indian tragedy called PCM and PCB. God bless India and its inheritance from the British. Oh, we got ruled so much that we said, now biology, you go your way, math, I will go my way. And I used to hate biology in school. And I was doing workshops for young kids on falling in love with math. And one kid asked me, you don't hate any subject? I said, yeah, I still hate biology, I think. And that day, and then why are you telling me to fall in love with math or, you know? And then at that day, I said, I'll not do this workshop again until I fall in love with biology. And then I said, blood travels 60,000 miles in my veins and arteries, which is multiple times the circumference of Earth. 7 trillion cells are changing 10,000 times in my... And then I started to do math with all the biology became math for me. And I said, oh, but biology is math. But every time I talked about math and biology together, I was committing a crime in school possibly, because these are two different areas. You do them in your silos. And, you know, all this COVID-19 tracking and all of that was, I mean, this is a biological problem, so-called, but mathematicians were solving it. The vaccine creation, all of that. Psychology. As distant as you'd say it, you know, it is. I mean, quantum physics talks about consciousness relates to psychology. There's all kinds of analytics with psychology that you do, market research, analysis, studying consumer patterns. All of that is math, and we don't have too much time, so I'm not going to. A lot of geography. What rate are we melting the ice on this planet? What is happening? How, what are the sort of shifts? Saying 0.1 degree and 1,500 kilometers away. There's a lot of math in geology. I mean, you need to look at what's happening, how the Earth's plates shifting, and you need math. You tell me one subject which is humanities related that doesn't need math. Not possible. And so actually to say that, oh, I will survive without math is the worst thing you can tell your kids as counselors. I mean, we looked at the game theory and, we can talk about sociology and we've completely run out of time, but using human conflict, music, integration, you are actually putting notes together. What is music? It's actually taking, yesterday Krish was showing the math with the music. This guy is a techie, IT guy, he's creating music, and there's so much math, there's so much rhythm. Everything is music, actually. If you see coding is also like musical. The fundamental tools were actually Aryabhat gave us 0. But, India is the origin. How can our international friends who are here, but we are all born to be mathematicians. Not a mathematician per se. We are born to see math everywhere. So I'd really like you to think about integration of mathematics with everything that is in our lives. And we know these things, so I'm not going to, we wanted to leave 20 minutes for questions, so I'm not going to get into too much, but these are, students who love math. Like me, I became a teacher, school teacher. I used to sing in my class at times. Ian was talking about proof. And the moment you tell a kid, prove that, he feels, oh my goodness, now what do I have to prove? I have to prove how good I am. Well, I would say, prove that a line drawn from the center of the circle perpendicular to the chord bisects the chord. And I would do it with emotion, with body movement, with holding a circle, with bisecting a chord, demonstrating what I mean by it's the way math is presented to people. You got to get them over they can see math is in every career, and every career and college counselor needs to know that. I mean, and these are the careers that are directly linked with math, but even an animator, a forensic scientist, they take stuff and measure the drop of blood, like the size and what angle the blood has fallen. Now I'm investigating a murder. I just don't need to know what is, what's the metric and what blood group this is. I need to know what angle that blood drop, what is the size of that drop, and it tells me a lot. Everything else, jewelry design, all you ladies, you love jewelry and you hate math. You, how can you? This beautiful circle in your, madam. If I increase the radius too much, you'll give it up, or I decreased it too much, you won't touch it. I mean, come on, there is math everywhere around us. And why is our student getting scared? Because we aren't talking enough about where there is math in their life. Political scientists, elections are won and lost on math. It's not won and lost on emotion and speeches, on math. Urban planning, architecture, a pilot, God bless him if there are a lot of pilots who don't know too much math, but still they have to know. They put the wrong quantities, they do the wrong divisions, get the ratios wrong, and thrust and whatever else. You're in trouble, buddy. You're on the 36,000 feet. You did some bad math on the ground. God bless you now. You're going for a new career with God. So supply chain management, astronomy. Ian just talked about how we would have missed by 1,500 feet. Indian scientists do good math, and it is in our genes to do math. So please keep encouraging your kids. And I think my last point is math's really something that I found made me become more conscious, made me more aware, more logical, made me deal with my emotions better. Math helps develop a certain part of the brain that actually brings well-being. You need to reason your way out of situations in life. Math helps you to reason. It helps you to have a structure and a way to think. Math is actually, Ian already talked about these things. I talked about conflict resolution is rooted in math, and husband and wife, if they are good at math, they'll solve their problems. I tell you, most of the time that I actually started to ask this question. I knew, and being with a senior university professor, I was obviously very nervous. I'm going to have to present with Ian, and I started to say, okay, husband and wife, I called those couples who I knew were always fighting. And I checked how many of them didn't like math. And I figured that these husband and wives who are fighting more actually disliked math. They never did math in school. And I was looking at, Preeti, my wife, she loved math, although she's a doctor. And so I said, good, this math thing works in husband-wife relationships also. And then, develops agility and flexibility to approach problems from new and different ways. We really need that. And persevere. People say, Ganesh, this is preposterous. And, you are saying that you are more peaceful because of math and, mental health challenges. Well, actually, yes. When you've had balanced development of the brain, when you've got a feeling brain, which is the limbic brain, and your reptilian brain at the back, and your this part of the brain, which is the thinking brain, and when you develop the thinking brain, and when math helps you develop the thinking brain, which is 40% for us. By the way, cats have 3%, dogs have 7%, chimpanzees 16%. And that is the gift of the law. That's why we are 8 billion and tigers and lions are only a few. Such a large thinking brain. And what is that one subject that allows you to use it well? That makes you make it happen? What is that one thing that is in every subject? And so that is really what our children need to see. When you're counseling children, show them that. And you could counsel them differently. We teach some of this stuff at the IC3 Institute, but you got to be able to say it in conversations. Financial literacy, etc. Back over to you, Ian, to actually facilitate the closing.
I will just wrap up very quickly so that it's a chance for you to ask some questions as well. I want to return to this last point that Ganesh made about perseverance. Perseverance is such an important thing, and the ability to work through struggles. And this is something that many of our students, this happens to many of our students in the classroom on a daily basis. The students that it doesn't happen for sometimes are our strongest students who don't see as much challenge in the classroom. And I think it is a really important thing for those students. Those students deserve to be challenged as well. Those students deserve the chance to fail and then to learn that they can succeed after failure. And that's something that can happen in the math classroom. And I think it is incumbent on all of us as educators to try to continue to evangelize mathematics, to evangelize the importance of mathematics, to show where it goes, to think about where is math going. In the last year, AI all of a sudden has become one of the hottest topics in education. That's math at its core. And I think to always keep in mind and always ask our students, where are these disciplines going to go? We see right now problems in our world. I think we can identify that there are at least a few problems in our world, globally, in Canada, in India, everywhere else. We need students, our young people now, to be our leaders in 10 years, in 20 years, and 30 years. We need them to help us solve today's problems, but we also need to teach them in such a way that they will be able to solve tomorrow's problems. And we don't know what those problems are. So we need to teach them to think. We need to teach them to be resilient. We need to teach them to embrace all of these challenges. So thank you for not running away when we said the word mathematics. And thank you for being here today.
Questions? Yeah, question or? Yeah, so we'll try to give as many people a chance to speak as possible, and so if you can keep your comments or your questions brief.
Hello. Yeah, so I just wanted to add something on a light note. I'm told that husband and wife, you can actually understand if both of them are good with mathematics. I have some different opinion. If husband and wife both are very good with mathematics, sometimes they are good at calculations. That might create problems. And secondly, like I have been seeing that, women who are aging, or men, anybody for that age, if they are continuously doing some kind of puzzle solving or Sudoku games or other kind of things, the brain is still intact when they are aging. So this is something which I feel everybody should be doing. And my question is, many of the students who are actually not taking mathematics at after 10, what do they do? Because for all the entrance exams, you require reasoning and other kinds of reasoning, which requires a big amount of mathematics. So as a career counselor, I face problem that, they come at the last moment and then they tell, how do I cope up with the entrance exam? Yeah.
I think we leave it too late to inspire our children with math. When he's already fallen out of love, it's really hard to bring them back. So you really need very special skills as an educator to get people who are disliking the subject. It is a reality, even for business entrance, whatever area that you are going for, you always, I mean, people talk about the SAT a lot here, and well, math doesn't matter whether you're applying for a, art as an art major or whatever. So I think the solution is actually quality teaching in the classroom, and the counselor having enough insights from what we've shared. You can see this presentation on video on YouTube later. But his work actually, and the entire work that the University of Waterloo is doing in this CEMC is around that. And it is recognizing that we don't want young people giving up. Is like giving up on a lot in their life. So I think as a counselor, it is so important to tell, your school ecosystem, in your school ecosystem, tell people that make math real for kids and encourage them not to drop it, even if it feels like a punishment for some more time, but you can actually make it real, make it come alive in the classroom. I think that's the key, and you should drive that message through your school. Sorry, we'll let Ian. Yeah.
I'll just add one thing to that, which is recognizing, I believe anyway, that most of us here come from a secondary school or senior secondary school area. Ganesh said, it's important that we don't leave it too late. 10 years. And it's so important that our elementary, our primary school teachers help inculcate that love of mathematics into students, and that they themselves, that we support them in not being afraid of maths, as certainly in our country, so many elementary school teachers have very little background in mathematics. And then they don't inspire as much interest in the subject. And that, I think, is a really important other thing too.
Get Swagat had asked, yeah, please.
Thank you, Professor Ian and Ganesh, for this beautiful thing. When you asked, like, what does math mean? Magic.
Yes.
One of my classes is called Mathematicians. And if you'd allow, can I just comment certain things for all the counselors with respect to math, because it's something which is very close.
Sure.
So, like, when you look at economics, Fibonacci retracement, go figure. The number 666, right? That has to do with gematria. Figure out that sociology, the history behind it. The Euler's constant, 2.71, that is with continuous compounding. You see it everywhere. And like you said, that, math is that one subject that people fear. It is a tool. It's a universal language. I connect with students who do not know English or Hindi or any other language. But when we talk math, there is that connection. And thank you so much for doing this. Yes.
Thank you. Yeah, there's a question here. We'll give ma'am a chance, and yeah, what's your
Yes,
question?
this looks very inspiring and very, when we talk about it, but when we come back to the practical aspects of being an Indian school. So when we grow up from grade 10 and we go to grade 11, many of our students who choose maths, who like maths also, are not able to cope up because the system is like that. The boards are like that. The difficulty level at 11 is 4 times more than the grade 10. So we do not force the students to take maths. That is why we can make a change at our school level, but able to make a change that easily at the central level. Centralized, it's centralized.
Yeah. Thank you for your question. And whether the student takes math in school or no, in class 11 and 12 is not the point. What I was really talking about is they continue to look at math favorably, that they continue to use math wherever they go. I mean, so they may just need to prepare for an entrance test which will need math still, right? But I think the key here is, when IC3 began, I was told this is not possible. 7 years back, nobody will come for counseling. You call them for awards, they will come, but nobody will come for too abstract. We have to work within the system. CBSE will do what it has to do. IB will do what it has to do. Whatever other the curriculum, I think as educators, we don't become victims of the system. Doesn't matter how abstract. I mean, we were doing a regional forum in Myanmar, and there was somebody who came and said, but our system is this rigid. It's like, I know some of the structures are very rigid, but within that structure, it is the educator that holds the power to inspire and to transform. And so I would say, I don't care what the syllabus is. If I was given a chance to teach your 10th graders or your 8th graders or your 11th graders, I would take the school to inspire the kids and to they would. But it's a very logical point. It's perfectly fine. We're in a very grades-based system. They give up math because they don't want their grades to go down in 11 and 12. But tell them to keep looking at math on the side and do it. I mean, fair enough, if you're in the system, but they're going to need it in their life. They're going to need it, and it's going to be helpful. Yeah. Did you have anything to add?
I think one thing to add there is, again, acknowledging that the Indian system is not as familiar to me as other systems. I do think that we have seen in the work that we do around problem solving, that the students who have exposure to problem solving, have exposure to the challenge of problem solving, act in their curriculum. We find among our students at the university, the students who have written math contests, along with having great grades, their grades are good predictors of their success, but it's their performance on math contests that is even better predictor of their success. We have students, Sita was saying to me earlier, who say, I'm preparing for my IIT exams by using the CEMC problem solving materials as the tool to help them prepare. So I think trying to find that balance in ways that is so hard to do, I think can help too.
We're complete here. Madhulika ma'am was the one who had raised her hand. I saw it. So, and we'll take this as the last question, and then we can interact after the session. And I know all of you have to go and set up your tables as well, because we have the high school exhibit. So I want to be conscious. Yes, last question.
Thank you, Ganesh. Ian, I'll carry forward the point that you said that even 10 years is quite late. You know, we're all inspired, and as school leaders, the ones who want to make a difference, I think teacher empowerment is the key to really solve this problem, irrespective of the system. Now, elementary school teachers or the entire math team doing math from an elementary level to the senior secondary, many of them themselves are, they are part of the system where they have also had math phobia. And elementary school teachers are supposed to do the mother teacher role also, right? And doing math. How do we really empower them? Because pre-primary or elementary education is the foundation. And as we see the transition, grade 6 up, there is again a huge dip and the fear comes there. So how do we help our team members and empower them to take up the approach you are talking about math? What's the support we can get to really take it on from here?
Thank you. I think this is a really important question, and there are two parts to this. One part is the training of future teachers, and one part is the professional development for current teachers. And on the latter front, this is something that we are working on right now. We are working on creating materials and programs. We're not there yet, but we're very close to helping work with primary school teachers where they really need that. And they need people who are doing hard jobs with many different challenges. And if we can help inspire them to be confident in math in front of the classroom and not to pass that phobia on, that's important. I think on the teacher training side as well, there are things that can be done as part of teacher training programs to make sure that we for teachers going into whatever level they're going into, have that chance to feel successful about mathematics, to feel confident by presenting the right kinds of materials to them, by giving them the resources that they can then take to those classrooms. I think it's an important problem. And I think one last point on this is that I have a bag upstairs in my hotel room that says, teachers make all professions possible. And I think this is one of the most important points about education, is that nothing else is possible without you and the work you're doing, and your colleagues and the work that they're doing. And it behooves us as nations of Canada and India and global citizens to really remember that and to support our educators as best as we can. Ganesh, do you want to?
Yeah, I'm going to say thank you to everybody. I have to go to the presidential forum to close it out, but Ian can take another. I could see some principals really very strongly wanting to. So we'll give this another 5 minutes here. Ian, I'll let you facilitate this.
Sure.
Sorry, my role here, I have to just be super on the dot. Thank you very much, everybody, for being here.